Model deployment is merely an engineering task of making an ML model available for the use in the real world. The term is frequently used interchangeably with making a model available via real-time APIs. However, we should consider model deployment in a broader sense. This course will walk you through the major factors in model deployment and what they mean in the various contexts. So if you feel the need to dig deeper, stay tuned as we are going to bring all the information that you need right on your screen. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments.
So what we'll do today is we will talk about a model deployment. The way I plan to take this session is I'll give you a little brief about how models are really deployed in real life. So we will talk about the model deployment architecture, different ways in which a model could be deployed. And then we will look at two case studies and we will use R Shiny as a base. So as I said, we'll be using R Shiny to learn that how model needs to be deployed. There are two case studies which I plan to take in this session. The first case study would be more telling you that what are the capabilities of R Shiny. And then in the second part, we will look at a data set and we will see that how once the model is built, how the same is deployed in a real life scenario and how business really uses that to make the prediction. Okay, what exactly is a model deployment? I'm sure all of you are well aware about it. Model deployment is the application of a model for making predictions on new data by taking user input. Fundamentally, when we are building a model, we are actually building a model on a historical data, which means something which has already happened in the past. That's the data which we use to train the model. And then some part of that data itself, we use it to do a validation or a testing. Okay. In all these scenarios, at least till the validation stage, we are only talking about what has happened in the past. The real test of a model, or you can call it as an acid test of a model, really happens when you put this model on an unseen data set. Unseen is very important because till now, I'm sure what you have learned is even if you're making a validation set or a test set, what you have is a value available for a dependent column. Whether you're talking about a classification model or a regression model, you always have a value for a target variable available to you. When we use a word unseen, that's the time when you do not have this target variable and you are actually predicting it. Okay, and that's a real prediction and that's what we call it as an acid test. So for us to be able to do that for a data which is coming in, which has not been seen by the model, we use a model deployment. So, and we know that generally building a model is not the last step, but when we are learning to build the model, then what we say is when you have validated the model and you have looked at the performance, we consider that as the last step. But practically, I'm sure all of you are well aware about it. The model needs to be deployed into a real environment or into a production environment. And that's where we say that now I've reached a stage where I can say, yes, I have completed the modeling. May not to be a great extent, and that's what I'll probably spend 2 minutes at the end of a session to just give you a little brief. Whenever the final model is ready, its intelligence is used to predict on newer data. Intelligence is a very, very important word because when we are using an algorithm, the algorithm is actually learning from the data. Okay. Now, when I put it onto a test, which means when I put it onto an unseen data set or a newer data, what I really need is a graphical user interface. And through that graphical user interface, I allow the data to be inputted. And once the data has been inputted, I would like to run the model, right? So the two words which are key here, one is the intelligence intelligence which is available in the existing trained data based on which the algorithm was developed. And second is a graphical user interface. Okay. Some common examples, and I'm sure all of you are well versed about this: chatbots, auto-generated text suggestions, and Facebook auto text suggestions. These are some of the platforms which have been already developed, and these platforms, they actually use the input which is given by the user to do a prediction. What are the features of a model deployment architecture? Now, as I said, that when you are actually deploying the model in a real time environment, there are something which has to be kept in mind in terms of an architecture. Once you are deploying the model, it's like any other application which you could have built in. If I need to take an example here, let's assume I have built a Java application, or I have built any other application using a Microsoft as a platform. When I'm deploying that application, there are certain key needs of a standard application which is developed in any platform. Similar to that, when you are writing a code in R, and this R code has to be really deployed into a production environment, there are some key features, or there are some key requirements from an architecture perspective. First requirement is modularity, which means the application has to be modular in nature. And I'm sure people with the programming background will be able to appreciate that. More modular the application is, easy for us to look at a specific block, make the changes, or if there is a need, remove the block or add a block. So modularity is a key. Now herein, when we are making a model, then as far as the pre-processing steps are concerned, if I can use a word, that is almost mandatory that these pre-processing blocks should be modular. When I use a word pre-processing, which means, for an argument's sake, if there are certain variables or features in a data set which are not normally distributed, we use certain techniques to make the features normalized. Or we use certain methods for doing an imputation. Or we use certain methods for finding out the outliers. Or we use something for a feature extraction. All these are pre-processing steps, and they are necessarily required to be modular in nature. Reason being, in any model which you develop, you can easily say that 60 to 70% of the effort really goes into a pre-processing. Subsequent to that, when you have pre-processed the data, you are using the available algorithms to build the model. Okay, so there is a major effort which goes in terms of a pre-processing, and whenever there is a need which comes in for making a changes in the model, if the model really bombs in the production environment, then you go back and look at these pre-processing steps, right? So that's why I have said specifically for the pre-processing steps. The second requirement is reproducibility, which means there should be a compatibility available, and I'm sure this is what you would have realized when working on R. If there is a new version which comes in, then you should be able to have the software available to do a update or an upgrade of the existing library package. And the model which you have developed, this needs to be validated and this needs to be checked so that this is compatible, right? Now, if there are certain portion of the code which you have written which really works well on the backward, so the model has to be such that it works on both the backward and the forward environment. Scalability is not just related to a hardware. It doesn't mean that when I have 100 users, I put in one machine. When number of users increases to 200, I put in another machine, and I have a linear increment in terms of a hardware which I need. Definitely not. You need to ensure that the way the model is written, it whenever there is a user interface, or whenever you have the input which is taken from a user and you respond it back in terms of an output of a model, it should not take too long if the number of users really increases. Okay. Extensibility, which means I should be able to easily modify it for a future task. Now, these future tasks could be related to something new which has come in the data set. Okay. Testing, the ability to test variation between model versions. And herein I'll spend additional 2 minutes. Whenever you are making the model, it's an iterative process. It's an iterative process in terms of doing a pre-processing. It's an iterative process in terms of validating the model using multiple algorithms. So what really means is I need to have a version control kind of a software available. And in a real life, when you develop the models, these models, they are kept in the software system wherein they are being version controlled. Okay. So what happens is if I have something new which has come into the trained data set for which my model has not learned it, which means if let's assume for an argument's sake, we are talking about a banking data set wherein we have developed a model to predict if the guy will default on a loan or not. Okay, very standard application. Now, based on certain parameter values in the algorithm has learned. Let's assume there is an absolute new scenario which comes into the bank, and for that new scenario, my model was not able to predict rightly. So what it really means is every model has a life. Now, based on the industry, based on the scenario, this life could vary from 3 to 6 months. So when I say the model should have an ability to be able to test between the different variations, which really means if for a new feature or for the new set of values which comes in, when I go back and rebuild the model, I should be able to test this new data set or test this new feature or test this new set of values across the models which I have developed. Okay. Automation. This is, I'm sure you can appreciate the fact of automation. More the manual steps you have in terms of running the model, more time it will take for a user to get the output as a result, right? Now, this diagram gives you a broad overview of all possible ways in which a model could be deployed. Okay. Now, we will read this table from a column perspective. So we will say what is pattern 1, what is pattern 2, pattern 3, and pattern 4. These 4 patterns in which a model could be deployed has been compared against the training, prediction results delivery, latency for prediction, and system management difficulty. Okay, I hope you're clear in terms of how the table needs to be read. Now let's look at pattern 1, which is a REST API. REST, I will talk in the next file in a little more detail. It's a representational states transfer. Okay. What it really means is when I'm developing a model, organization already has an application which is running it, right? Now, these applications could have been developed in any platform. Let's assume I'm talking about a bank, they have a legacy which is running in probably on a mainframe. Or if I'm talking about another environment where you have an application in Java or any other environment, right? Now, what really is done is you write a API, you write a application program interface, and I will really not go into a detail of how the API looks like because I understand not everybody would be from a programming background. So you actually write an API to interface with an existing application. So what happens is you are training the model in a batch, which means I have pulled out the data which was in historical data already available and the model is trained, right? Then I use the trained model and on the fly I validate the model, or on the fly I do a prediction for a new value which comes in. The results are delivered through an API call itself. Latency for a prediction is so-so. Why I said so-so? Because based on how well you have developed the application, the result might just come immediate or it might just take a little long. If the data set is too small on which you are doing a prediction, maybe you'll just get the result immediate. Okay, system management difficulty is so-so because you would have realized here, I have the entire hardware environment which is available for the batch mode, right? Probably you'll appreciate the last point once I move on to the pattern 3, and that's where I'll explain it to you what it is. Pattern 2, which is a shared DB. What is a shared DB? Let's consider a scenario wherein I have applied for an insurance cover. Okay. Now, what really happens is the person comes in, takes an application from me, and says that in next 2 days he'll tell me what is the next step, whether I need to go for some underwriting test or what will happen. So what is happening in that scenario is there is a model which has been trained on a batch data, which means I have a database. DB stands for a database. I have a database wherein the model is available, and all these new insurance applications which have been collected by the sales team, I put it through a batch and get an output in terms of what is the risk associated with each application. Okay. So because I am doing a prediction in a batch, that's why we say prediction is a batch. Prediction result is through a DB, which means the prediction results in terms of a risk associated with each application. Let's assume I have fed 100 applications there. Then the result associated with all these 100 applications is really stored in a DB, which I can refer it. Latency for a prediction is high because it really depends on when I'm running a batch. System management is easy because everything is in offline mode. Training is in offline mode, prediction is in offline mode. Okay. Pattern 3, which is a streaming. Now this is the delivery option, or this is the model deployment option, wherein we are talking about everything which is almost online. Okay, almost real time. When I use the word almost, which means the difference between the model being developed and the developed model being used for a prediction and further update happening on a training model, it's almost immediate. That's why you have a training as a streaming, which really means if I need to compare the difference between a batch and a streaming, then it is not that the model has been trained once and kept. Maybe when let's assume I started the model at 9 a.m., right? The record which comes in at 9:20 a.m., the training has been done from the new data which has come from 9 to 19. Okay, I hope you understand the difference. I'll just repeat it one more time. In a batch mode, what happens is when I start the system at 9 o'clock, I already have an algorithm available in my system, and it will run maybe for an argument's sake and just to understand it, maybe that's the same algorithm which will run for the entire day. Okay, in a streaming, I start the system at 9 o'clock. At 9 o'clock, I have the trained model 1 which is available. Probably at 9:05, I have trained model 2 which is available, which means the entry which has happened from 9 to 9:05 has been considered again by the algorithm to rebuild the algorithm. Okay, herein the prediction is also streaming. Results are delivered through a message queue. From an understanding perspective, and assume this is kind of a pipe which is available wherein there is a continuous flow of an output which is happening. Latency for prediction is very low. System management is very, very, very difficult because you need to keep the entire system for training and system for prediction online. Okay. Pattern 4, which is very similar to pattern 1. The only difference why the training is streaming because you're using a mobile app. So it's based on a gadget. That's why we have a pattern 4 available. When I was talking about the R Shiny, in an R Shiny application, you can have a pattern 1 which is available. Okay. So REST, as I said, is a representational state transfer API. API interface is required to integrate with modern enterprise application. On-demand analysis by GUI, which is drag and drop prediction interface, which allows user to get the prediction when they need them. Okay, and this is what we'll be using it in our Shiny, the second one. Scoring code export, which is model is available in an executable jar file or as a Java source code and can be deployed anywhere Java runs. Okay, so this is like an executable code which I make it, and that's what I deploy it. You do not worry about the jar files and anything like that. It's just that I wanted to share with you an example of saying if you already have an application available, then this is also one of the mode of doing a deployment. Standalone scoring engine, it's a separate staging and production environment so that model can be tested and implemented in a stable. Now, staging and production are very common terms which are being used for any kind of an application which you deploy it. Staging in a layman form really means I'm setting the stage right before I go and do a production. Okay. Two other methods of doing a model deployment, which is cloud and big data. Now, on a cloud deployment, there are multiple choices available, right? Now, why I have made this separate file for this is because I really want all of you to go and explore it. Because for a cloud development, there are different kind of clouds. So first you need to make a choice whether it is a private cloud, whether it is a public cloud or a limited deployment cloud. And then all any of the techniques which we spoke in the past can be used. Okay. Big data environment, the fundamental difference between a normal environment and a big data environment is herein we are talking about a data set which is big, and number two, we are talking about an environment which is streaming. Okay. Big data environment basically is used when you have a huge data set and you have a need for doing a model training and validation and testing in a streaming environment, which is almost real time or almost online. Now, what are the platforms which are available? So Amazon Web Service, R Shiny, there are multiple platforms which you have it. What we will be talking about is R Shiny. What exactly is an R Shiny? Shiny is an R package that makes it easy to build interactive web apps straight from R. Okay. How do I host my R Shiny app? It's very easy. You have to go onto this link, sign up for an account. Okay. When your app is ready, you can publish your app by clicking on the publish button available in RStudio. And that's what I'll show it to you once I move on to an RStudio and follow their instructions. For the first time user, it will ask you for a few package installation and that will happen automatically. Just to give you a little idea, and I'm sure Great Learnings can confirm it to me, all the hackathons which are being organized for all of you are being hosted on a Shiny app like this. Okay, so this is already in use as far as you as a user is concerned. What is the syntax block of R Shiny? The first thing you have to use is library Shiny. The entire Shiny app works on two blocks. First is a UI block and the second is a server block. Okay. What is a UI block? It actually assembles an HTML user interface. Okay. People who are aware about HTML, they will be able to understand what I mean by an HTML user interface. But what it really means is that the advantage is in an HTML user interface, you need to really have an understanding of what are the tags which are available, how do you write a script and all that. When I go back and show you the code, then you will realize you do not really need that kind of an understanding. There are certain functions which are available which gives you the required functionality. Certain functions, what I mean is, let's assume you want to do an input, you want to do a plot, you want to create a tab. All those functions are already available. Now, UI is a user interface, right? User interface in a layman terms is something which will just get displayed. Now, if I want certain processing to happen, if I want the display to change based on certain actions, if I want something different to be displayed based, and we call it as a reactive calls, then I write that portion of the code in a server. Okay, so there are two blocks which you need to write it. Shiny app, it combines the UI and server into a functioning app. So if I am using a R console, which means I'm not using an R Studio, I'm using an R console, I can just say Shiny app UI is equal to the UI, which I have mentioned there, and server is equal to server. Okay, and this app will run. Now, initially when I'm running the app, and if I have not published the app, I can write the code in R Studio and test it. When I actually test it, and that's what you'll get to see, I go onto the net. I go onto the local host where the application gets hosted, right? Subsequently, I can publish it. The only difference between a local host and a publishing it is, instead of using my machine, I am actually publishing it onto a server. Okay. So just to go back one more time, library Shiny is the one which you require. Two blocks you needed, UI and server. UI has the functionality which is for a user interface. Server has the functionality which is the instructions to do a build, to do a modification, to do a reactive calls. Shiny app combines the two, which is UI and server. Now, what we will do is, as I said, we will use two case studies. The first case study I'm using is life expectancy. This is a data set which has been picked from a Kaggle, and I'll just spend a couple of minutes in terms of going through what the data set is. Then I will run the app, and then I'll show you how that app has been written. Okay, I will go away from the presentation mode. Now, this is what the life expectancy file is. If you really want the link, this is where the file is in the Kaggle. Okay, now what are the fields available, and that's where we'll understand. I really don't want to spend time in terms of reading the problem on a Kaggle. Through the fields, we'll be able to understand what is the problem. So you have a data available for different countries, year, status of the country, which means whether it is a developed or a developing status, life expectancy in age. Now this is the target variable for us. Adult mortality, which is mortality rates of both sexes, probability of dying between 15 and 16 years per 1,000 population, infant deaths, number of infant deaths per 1,000 population, alcohol recorded per capita consumption, percentage expenditure on health as a percentage of gross domestic product per capita, hepatitis B, then measles, BMI, under 5 death. Under 5 death is number of under 5 deaths per 1,000 population. Polio, this is an immunization coverage, 1 year old. Total expenditure, government expenditure as health as a percentage of total government expenditure. Diphtheria, then AIDS, then GDP, population, thinness 1 to 19 years, which is prevalence of thinness among children and adolescents for age 10 to 19. Similarly, you have thinness of 5 to 9 years. Income composition of resources, which is Human Development Index in terms of income composition. Schooling, number of years of schooling. I know I've gone through this a little fast, but let's just spend some time here. So this is what the status is. This is the life expectancy, which is in years. This is the mortality rate. This is the infant deaths, alcohol, percentage expenditure. These values are available in percentage. Which is hepatitis B, measles, what is a BMI, under 5 deaths, polio, total expenditure. So this is what the data set is. Okay. Now, normally, in case of when you are making a model, what you will do is you will start with setting the working directory. You will load the data set. You will look at what is the variables in terms of doing a univariate analysis or a bivariate analysis. You may start with a describe, look at univariate, bivariate, do a multivariate analysis, maybe make a correlation plot, and then do a prediction, right? In a very small or a nutshell, you can say these are the steps which you follow. Now, what I will do is, before I show you how the application has been written, I will just run it. Right? This is an R Studio environment. This is in file which I have it. I'm saying run app. So what do you see here? There is a screen which I get it, right? And this is a screen which has been opened on a browser. You can see a 127. 127.0.0 means a local host for me. What are the options which I have put in here? There is a title which you see here. There is a logo. Then you have an option to change the theme. Now, if I just go down, now I have the description which is available here, right? I can change this. I really want to see 25 entries. If I just go down, I have 25 rows being available here, right? Let's just go up. Right? I can search for something which I really wanted. So let's assume I am looking for a 19.1 as a BMI, right? The moment I say 19.1, I have this as appearing as the first record here. I can do previous 1, 2, 3. So this is like a GUI interface to looking at the data. Now, I can explore the individual attribute. Now, this is one kind of a graph which I have made it. There are options available to make multiple graphs. So let's assume I want to study country is a variable. Let's just go back onto a data set one more time. And let's look at the data set. Country as a variable is categorical, right? So that's why when I'm making a plot, this is the way the plot is being shown here. Let's change this to life expectancy, right? So I immediately get a scatter plot. Let's look at adult mortality. Again, a scatter plot, which I get it. Now, let me just pick up another, which is a population, which means I can select a variable dynamically and make a plot. Okay. Let's assume I want to visualize a histogram along with the density. So by default, it's showing me a year. I can look at, and let's say infant deaths, right? Or let me pick up another variable, which is again an adult portability. So I'm able to make a histogram and density. So I'm able to select a variable by through a drop down, and the graph gets changed automatically, right? This kind of a visual interface, something which I have to write it in R, will probably take good amount of time in doing it. If I want to make a box plot, right? For the numeric variables, let's select alcohol this time, and you get a summary being displayed here, right? You have a box plot. So if I want to see if there are any kind of outliers which are available, I can make a box plot and look at these values side by side. I can do a comparison or do a multiple attributes analysis as well. So let's assume I want to compare the adult mortality with alcohol, right? And I'm able to see the log value and the square root value. So you have an option of doing any other transformation as well. Why I said I want to see the log and the square root? Because immediately I'm able to find out if I make a log or if I make a square root, if the data set was not normally distributed, will this make a difference, right? You could select any other mode also. So herein, any combination of two attributes, which means a bivariate analysis is what you can do it. The reason I've said a multiple attributes here, because I've just given two, you can give three and you'll get a analysis being done for three attributes together. Now, herein I'm making a correlation graph, right? So let's assume an adult mortality, and so I'm able to see the log and the square root value again. Okay. If you want a correlation to be printed for you, you can select the two variables and you get a correlation graph, right? I can keep adding the variables here. Let's assume I want hepatitis B as well. The reason you are getting a question mark here, because there are certain variables which are categorical in nature, and that's why you are getting a value there. Let's assume we select, let's just go back and look at the two variables which are adult mortality and let's say BMI. So I can look at the correlation graph. Let's just try printing this one more time. These are the values which you get to see, right? If I need to handle the missing values, the graph has appeared now. It was taking a little longer time. Let's just move on. When the graph comes in, fine, I'll just show it to you one more time. If I need to handle a missing value, then I can select here and I can say replace with what? I want to delete a record, I want to replace with mean, and these values will get replaced. Okay. I can do a predictive analysis online, which means I can use a GUI option to make a model. Herein, I have an option of finding out seed, which is required because I am calculating the value of life expectancy, and input I am giving as a seed value before I make the model. I'm sure all of you are aware what is the value of a seed. The point which I want to show here is you have an option to change the percentage of training data which you want to use, right? So let's assume I make the training data as 80. Target variable is life expectancy. I want to select the predictors. Let's assume I just want it on the adult mortality. So this is an output which you get it. Okay, I'm able to see a residual versus fitted graph, residual versus leverage, and this is what the model looks like. Let's assume I want to add infant deaths here. So this is what the graph looks like. Okay, so what we saw was there are many options which are available through which you can do a visual interface. Using a visual interface, you can do an analysis. You can do a univariate analysis, you can do a multivariate analysis, or you can do a, let's assume I want to see this. Okay, so these are the values which I have it, right? So correlation between adult mortality and alcohol is minus 0.20. I can do an imputation of the missing values. I have just given 3 options here. You can decide on the way you want to impute it, or I can do a predictive analysis. Okay, so this is what is a capability of R Shiny. Now, this is what I am running on a local machine. If I want to publish the application, I have to just press the publish button here. I will not do the publish right now because I just want to show you what the application look like. But this is a button which is available for doing a publish. Now let's spend a little bit of time in terms of looking at what the application is. Okay, let me just. So what I am doing, I am loading the library Shiny. Rest all libraries, I'm sure you all are aware about it, except Shiny Themes. Shiny Themes is a library wherein you want the themes to appear. Remember, you saw the themes, which is like this, right? I want to change a theme, then this is how it will look like. So which is more from a visual perspective if I really want to make a change. Now let's look at the code. I will not go into every line, but I'll just give you a little idea about it. You have an title panel, which means the title which appears. Then you have an option for putting different headers. I am more interested in showing you how do you build those histograms and all. Okay. Now, let's look at this. I have said explore individual attributes. This is heading 3. What we are doing here is select input, right? This select input is selecting the input from a available data set. Life expectancy is the variable or is the object or, or in which I have stored the file. And when I say names, it shows me a drop down list of all the names which are available. Okay. So this is a select input. When I say H for explore data distribution, herein I am doing a plot output, sorry. This is selecting the variable which you were able to see on the left side. This is plotting the output. Okay. When I'm saying plot output, select distribution, let's just follow this and look into what I have on the server side. So this is what was the UI side which was available. Let's go back and look at what is the server side code. Yeah. So herein I start with server function input output. If you go back, this is what I showed you. This is how the block look like. So the UI was a fluid page. This is function input output. Now, if you just follow the one which we just now read it, what we have is output selected distribution. Selected distribution is the variable which got defined in the UI. The function which I'm using here is a render plot. Okay. Now this render plot, as I was telling you, there are inbuilt functions available. This render plot automatically allows you to make a plot of the selected input variables. Now, what I said, if this is not null, whatever is selected, which is from the input, right? Then I am making a plot of this selected input and calling it as distribution of whatever the input is selected. Okay. So the functions, important function which I wanted to show here is you have a, in the UI, you actually select the input. Select input allows you to create a drop down. You can have a select text wherein you actually write the values, and that's what I'll show it to you in the second case study. You have an option to plot the output. Now you also have an option that based on certain conditions, you display some result, which is when we actually get into a prediction, we want based on what the prediction is, certain output should come out. But these are already available functions and you really don't have to write the code. How these values get displayed is based on the code which is written on the server side. How server knows that these are the variables, that's what you give as an input by using the inbuilt functions like a render plot, render image, or render input. Okay, this is the way our shiny code is written. Now let's look at the second application. Now this application was more of wherein you have a data set available. I wanted to do a univariate, bivariate and multivariate analysis. I just showed you selected functions which are available. You already have a choice of, as I said, instead of taking the input from a drop down, you can probably write it and select it as a text. There are multiple options available and I would encourage all of you to explore that. In the second one, we are talking about a loan delinquency classification. We have 4 predictors and 1 binary target variable. So this is what the data set is. I'm sure you would have seen this data set multiple times when working on different projects or exercises. You have a column which is delinquent, term, gender, age, FICO score. Okay, I have just limited it to 4 columns because I just wanted to explain you how the data needs to be displayed. We need to predict for a delinquency, right? Now these are 4 columns data. The only point which I just want to make here is this data set, we have created some artificial rows here just to show you a point, right? So if you compare the rows which are available here with the data set which was given to you by Great Learning, that was a data set which is more genuine because but that data set had a limitation from the session perspective of only 2 or 3 levels, right? I wanted to show you how the model works, and that's where I have inserted certain rows. Now, so what we are expected to do, these are 4 predictors which are available. Looking at these predictors, we need to find out whether somebody would be delinquent or not. So what will happen? I have developed an application. This application is already available to me, and it's available in a batch mode. If I need to compare with the architecture which we spoke, let's just go back. Yeah, so I have the model which is already trained, available in a batch mode. I want to do a prediction on the fly, which means let's assume Anjana walks into the bank. There is certain variables, which is these 4 predictor variable data is collected by the bank, and based on the values, Anjana will be told at the counter whether her loan is approved or not. Okay, this is a little hypothetical scenario because I am aware bank will not tell you over the counter, but the reason is I consider this as a scenario because I just wanted to show how it really works on the fly. Okay, for an argument's sake, if we assume that bank has really decided to tell you on the counter that this is your loan is approved or not, so how the application would look like. So this is the second application which we have it. Let me just select this once and run it, and then we'll be able to see what is an outcome. Okay, now this is where I see the classification tree model. Again, I have added a theme here. You have a logo. Now, let's start with, you have 18 months of term. I'm a female. Age is 36 to 45. And let's assume my FICO is 300 to 500. When I say run model, what do I see here, right? I see I am not delinquent, which means the predicted value of yes is 0, right? Now let's go ahead and do some changes. Let's assume instead of 18 months, I ask for a 36 months loan. What do I get? Your loan is not approved, right? Now, this is where I said I have created certain additional rules, because normally in a bank, most of the time we opt for a loan which is of 36 months, right? Whether we are looking for a loan for purchasing an asset, or we are looking for a loan from an education perspective or whatever, generally the requirement is for 3 years. And that's what I said, 36 months loan, no. If I am a female, 36 to 45, and this is what my FICO score is. FICO score is too low, so I get a message, no, your loan is not approved. Let's change this further. If it is for a 45 months, your loan is approved, right? Keep looking at these predicted values, which is changing. Let's go ahead and make it 60 months. Oops, your loan is not approved. Okay. Now, let me go back within 18 months, and instead of a female, let me make this as a male. So for a male, if you are 36 to 45, the loan is not approved for 18 months. Let's go back, look at 36 months. Your loan is approved. Look at the value which is changing. No is 0.98, yes is 0.011, right? I have intentionally not made any change in the values. You can format it. I'm directly putting it from the predict model, because I really wanted to show you that these are the values, or these are the kind of values which you get it when you predict the model, and this is what you are able to see. Now let me just go back and change it to 45 months. No, it's not approved. 60. Yes, it is approved. Okay. Let me go back and make a change in the age. So let's assume I'm again going back, checking the 18 months. And instead of 36 to 45, let me select the age 20 to 45. Your loan is still not approved. Let me select 26 to 35, still not approved. Greater than 45, still not approved. Okay. Let me go back and change the FICO score. Let me increase this FICO score. If I run the model, it's not approved, right? Let me make this 500 to 700. No, it's not approved. Greater than 700, still not approved. Maybe let me go back and change the months, 36 months, right? So what you're able to see, how the model is able to say whether your loan is approved or not, this is what you would have predicted through a decision tree. Now, just to explain you a concept, the part which is a model summary, I have commented this. Let me just uncomment this and run it one more time so that you're able to see what the model looks like. Just give me a moment, guys. I'll just uncomment this. Now, what do you see here? When I run the model, I'm able to see an output here, right? I've intentionally commented that, but if you see what is the output, you get it. On the route, this is what you get to see from a model summary. This is how the route is. If term is 36 months and 60 months, if this is true, then you go through all this, right? If the term is 18 months or 45 months, then you just check for a gender. If it is a female, then no for a loan approval. If it is a male, then yes for an approval, right? So all these changes which you were able to see when I click somewhere is because of the way the model has been. Fair enough? So what we saw was that using an R Shiny, I can write an application and I can run it on a local host machine. If I really want to publish it, I can use a publish button here, or I can go onto the application which I'm able to see here and directly I can publish it from there. Okay. So this is what was planned to be covered.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments.